Activity C, parachutes. To get the gizmo ready, select the experiment tab, click reset, and make sure that air is selected. So you want to make sure that we're in the experiment tab. You have the little back arrow, make sure it's selected, and then click on air. Number 1, observe. Drag the objects with parachutes to the tower. The parachutes look like little backpacks. As the objects drop, click Open Parachutes. Compare how the parachutes affect each object. So you take and you grab a parachute there, parachute there. When you click play, make sure that at some stage you click your parachute, otherwise they'll just drop normally. You can click them early, you can click them late. All right. Do that with different objects. Form a hypothesis. How will the parachute change the air resistance and the terminal velocity of an object? So in this question, you want to talk about what will it do to the air resistance? Will it increase it, decrease it, or keep it the same? And also the terminal velocity. If you've forgotten, air resistance is how air pushes against an object as it falls. And if you've forgotten, terminal velocity is the maximum fall speed of an object until it cannot fall any faster because of air resistance. Number 3, collect data. Find the terminal velocity of each object when the parachute is open. So first, you're going to do the ping pong ball with the parachute. You want to grab your ping pong ball. And how you do that is you click play, grab and turn on your parachute. Now, I would suggest that you're using the 40-meter height and you're hitting play as fast as you can. That is your drop time. And then over here is your speed. So if you scroll over, it's 2.3 meters per second. And that's your time. To figure that out, all they did is they took your time and divided that by your distance, which is right up here. So you want to find your terminal velocity for each one. Also, you could click on the graph, and this terminal velocity shows around right here. Again, if you just reset, hit play, open parachute, you'll see that it's falling at 2.3. Find that for the ping pong ball, the golf ball, the soccer ball, and also the watermelon. Analyze. The watermelon is the heaviest, followed by the soccer ball, golf ball, and ping pong ball. How does the weight of the object relate to how fast it falls with the parachute? To figure that out, you can just run all of them. That would be the heaviest object, and that would be the lightest object. How did they compare in their fall times? Answer that in number 4. Interpret. Select the graph tab. How does the graph show when the parachute is open? What that's asking you to do, at what stage do you think I opened up the parachute? You can see it right here on the graph. At this stage, you can see the parachute opens and it changes how fast the object is falling. So talk about what you're doing is talking about how the graph looks when we are opening up that parachute. Does it increase or decrease your speed, or does it increase or decrease that line? Predict. Will the parachute work in a vacuum? Why or why not? This is your own thinking, so just write down it will or will not, or it will have the same effect, and then explain why you think that. If you're not sure, just do what it sounds reasonable. We don't expect you to know this, but again, just it's more important you write down what you're thinking and fill this in to your best abilities. Number 7, test. Use the gizmo to test your prediction. Did the parachute work? Now, if you're not sure how to do that, you go back to experiment, reset your gizmo. Now, they want you to do it in a vacuum, so you have to turn off the air and turn on the vacuum. Select any of the 4 objects, click drop, and then your vacuum. Notice that both of them fell at exactly the same speed, that there was no air resistance, so the parachutes didn't even open. We tested that. Did the parachutes work? Write down what you saw. Summarize. What controls how fast an object falls?